My name is Alina Perde, and I'm a technical lead at Three Pillar Global. And today I'm going to talk to you about infrastructure as code. So, we will go through some bit of history regarding the DevOps movement. How did we get to infrastructure as code? And what it offers? Why did we need it? Other than that, we are also going to present our use case, or my team use case, the context in which we are using infrastructure as a service, and how are we doing it. Some implementation details, and the challenges which we met through the road, and opportunities that we are still seeing for future work. So, in the past, maintaining a lot of servers was pretty difficult, as it took a lot of time, servers might have different configuration, and other than that, it was a pretty expensive operation. Moving infrastructure to the cloud allowed DevOps to easily deploy and quickly deploy new servers, but there were still a lot of steps that needed to be performed manually. What does infrastructure as a code do for us? Well, it allows the DevOps to focus on engaging more his abilities on more valuable things rather than doing repetitive routine things. And it also helps with the configuration. So using infrastructure as a code, we can have consistent configuration. We have consistent configuration since all servers are deployed using the same configuration files. So we only write it once and deploy it everywhere. With infrastructure as code, we allow writing all the configuration details that we need in a single definition file and then roll it out on all the servers. So it doesn't only allow us to easily deploy new production environments, but it also opens the door to exploiting new software development practices, such as test-driven development, continuous integration, and continuous delivery. You might wonder what it offers. So, through the fact that we have a single configuration file, and we can apply those configuration changes to all environments, it means that we have a portable solution, and we can port it anywhere, no matter on which environment we want to do that. And it can be repeated a number of times. So after creating a definition file, you can repeat it any number of times on any number of servers. And any change to that definition file, to those configuration files, can be tracked using a version control tool such as Git. The context in which we are using this. So, as I said, we have a team, and our use case of implementing infrastructure as a code is the following. We, as DevOps practitioners, we build an automation solution that enables, facilitates easy automation development and execution for our end users. If you are wondering who are our end users, well, our end users are technical people, such as software developers and automation engineers and QAs. As you can see over here, traditionally, an automation engineer would have to write the scripts, develop the libraries, and also take care of all the infrastructure development and execution environment, how all of these come together. With infrastructure as a service, we can remove the struggle of setting up the infrastructure and development environment, allowing the user to focus only on writing his scripts, developing his libraries, and taking care of the execution. And even more than that, with automation as a service, we are allowing our automation engineers to focus only on writing the scripts, on focusing on the test logic. And with automation as a service, we get to manage how we integrate all the infrastructure development and execution environment come together. You might wonder, why do we need it? Well, developers spend a lot of time setting up their development environment, Testers spend a lot of time setting up their testbed environment, and it can also get messed up. It can always appear problems. With infrastructure as code, implementing it, recovering, and getting your environment to work again, it can easily done. And my favorite problem from them all is that it works on my machine. Every developer says that. It works on my machine. I'm sorry, it's DevOps problem. Well, having this solution in mind, we can fix this because all machines will have the same configuration and this problem will not be anymore. And we can also easily integrate CI/CD process. Some advantages of having this. So users spend a lot of time on more valuable things rather than keep doing repetitive and routine tasks. And teams that are maintaining applications can define, provision, and self-manage their resources by themselves. And also, another important thing over here is that they can quickly recover from failures, rather than assuming that failure can be completely prevented, because that's not the case. If you are wondering how do we do it, how is our implementation, what did we manage to do with it? Well, we managed to implement infrastructure as a service through Docker. The Docker platform leverages Docker containers so that users can easily build, ship, run any application anywhere. If you are wondering what are Docker containers, well, Docker containers are instances of Docker images, and Docker images are constructed from the file system layers, and they share common files. If you're wondering why did we choose Docker and not VMs, well, Docker containers are an abstraction of the application layer, while the virtual machines are an abstraction of the physical layer. Docker containers start instantly, and they use less space. While we also have three main characteristics for Docker containers which make them more appropriate for this use case. We have three main characteristics for Docker containers. They are lightweight, secure, and standard. What does that mean? So they are lightweight. It means that if we are having a lot of containers running on the same machine, they can share that operating system's kernel. They use less compute, less RAM, and they start instantly, minimizing the disk usage. Also, they are based on open standards, which means that they can run anywhere, on any major Linux distribution, Windows, and even on the cloud. And they are also secure. So if anything goes wrong inside a Docker container, the effect will be contained in that single instance and will not affect the entire state of the application. So as I said, we have a web application which we provide in order to facilitate easy automation development and execution for our end users, which are automation engineers. These are the main services that we provide through the use of Docker. And I'm going to go through each of them in the next couple of minutes. Here you can see the draft of how we implemented this concept for our use case. We have the web application through which users can go and access all of these services. And the first main service is the image manager. Through the use of image manager, automation engineers can easily custom their Docker images with the desired environment that they want to have. Here you have an example of a Docker image. So as you can see, the first line, it tells from which base image it is constructed. In this case, it is Ubuntu. And it is built on top of Ubuntu, adding a few more commands. So copying the current folder into the app folder in the container, compiling it, and then running that app.py command every time we run that container. Users can create custom image in order to have the desired execution and development environment that they want. in order to develop their activity. After saving this image, they need to build it and then push it to the Docker registry in order that we can later sync it across all the locations. Our application runs in more than 8 locations across the globe, and we have a lot of users which need it. And in order to easily make it accessible to them, we have this Docker registry, and we push it across all locations. We next have the personal execution server. With the personal execution server, we allow users to deploy their own execution server in their execution environment. So by deploying their execution server in their execution environment, we make it scalable. And it also comes with Docker and all related Docker services already deployed.
I have a question. So is this a product you build, or this is a made-up app for this talk, or what is this?
This is the product that we are building based on this concept of infrastructure as code. And this is how it helps us in our day-to-day process. With container as a service, we allow users to deploy containers in their personal VMs. So building a container is pulling the desired Docker image from the Docker registry and then inside the VM, so that automation engineers can develop their activity there, they can develop, execute, and so on. Selenium microservice is pretty similar to the container as a service, given the fact that it raises a Selenium-ready container inside the virtual machine. And with testbed as a service, we allow our automation engineers to deploy the topology that they desire inside the execution environment. By topology, we mean to an arrangement of hosts and network configuration. What does it offer, the testbed as a service? Well, it lets us have a consistent testbed. It is a lightweight and scalable endpoint solution, and it's a simplified process in an all-VM testbed environment. And it is also platform agnostic. So as I already told you, our end users are technical people. So being the fact that they are technical people, they might need the possibility of accessing all of these services through some code. For that reason, we have built some Python modules. With the use of Python modules, they can access these 5 services and also some others that we offer them, not only through the web application, but directly through code, through the use of their automation scripts. If you look at this image, this is how automation with Selenium used to be in the past. So you had to go through all of these tools and manually install them, all of them, in order to have the desired development environment and in order to be able to do your activity. With infrastructure as a code, we can do all of this through Docker. So we use a Docker service with Selenium, and they can access all this functionality through the use of a button or a REST API call. And inside our Selenium containers, we have already there the browser version and type and the Selenium version. They are based on a compatibility map, as well as the VNC client. And last but not least, functionality for taking screenshots and recording video while testing. So we can obtain all of this through code. We don't need to manually set it up. Here is some code example. So in these 30 lines of code, we managed to deploy and VLAN configure 4 host test beds. We also have the Selenium start and the video recording start, and we redirect the user to the login page. So you can do all of this in only these 30 lines of code, and even more than that, we plan to further improve it. This is currently work in progress, And we want to obtain the same result through these 8 lines of code. If you are wondering what were the challenges that we encounter or what opportunities we see for the future, there are quite a lot. I will go through some of them. So, of course, when having a lot of microservices used by a lot of users, you might encounter with some scalability issues. We have managed to fix all of those scalability issues by introducing Docker Swarm. Docker Swarm, as I already told you, we have our application running in a lot of locations across the globe, and we have a lot of users in each of these locations, meaning that we have different usage in each of these sites. In order to accommodate this, we have Docker Swarm implemented so that we can easily deploy new Docker instances in each of these sites depending on our needs. So we have multiple users in a site, then we'll need probably 3 or 4 Docker instances, or maybe just one will suffice. And we can easily scale this by taking this approach. If you can imagine, we had this problem. I already told you about that. We are providing Selenium services. So we all know that Selenium is Java-based, and Java can be a really resource hog. So we needed to do something about it in order to be able to allow all these services provided for all these users, in order for them to have to be able to develop their activity. If you are asking if you should keep your containers running forever, well, I have a general common answer. It depends. So if you are using Docker in order to deploy services, then the answer is yes, you should keep your containers running. But if your interest is in using Docker with microservices, then the answer is that you might want to consider your containers being as ephemeral. Why is that? A good example is also Selenium, even in this case, because when starting a Selenium instance and testing with Selenium, you would want to start with a brand new session. You don't want any garbage from previous sessions, so you want to start brand new. In order to do that, you need a brand new container. And lately, we also had a request of simulating more than 1,000 containers, more than 1,000 VPN client to a VPN server. How did we manage to do that? Well, through the use of Docker. With Docker, we managed to raise one simple, lightweight Docker container with a VPN client. And through that, we managed to spin all the other Docker containers, all the other 1,000 plus Docker containers, in a matter of seconds. So these were some of the challenges that we encountered during the way and some of the opportunities that we are still seeing for future work. But all in all, infrastructure as a code help us in our situation in order to facilitate easy automation development and execution for our automation engineers. And it saved a lot of time, and it reduced the issues that we had before. So all in all, I think this is an idea that can be applied to many areas, and it can help us in order to have a better way of doing things and to improve and to focus more on more valuable things that can make our life easier. If you have any questions.
Your infrastructure as code, did you set it up before starting the development or after it?
Infrastructure as code was hand-in-hand process. So we worked together, setting up the infrastructure and developing.
Okay, thank you. The reason so I can justify my question, it was like there are two approaches. Like when you're in the team, you can do it like that, and I agree with exactly what you said. But there are others, like coming from the sysadmin, and they just plant their infrastructure as code, and you have to deal with that.
No, we work together.
Okay, thank you.
We've been working to this solution for the last 2 years. Our team is made of 16, 17 people at the moment, and we have like 1,500 users across more than 8 locations across the globe, in India, in the States, in Romania, everywhere. If there are any other questions, you can find me in the break on the hallway. I'm open to any discussions. Thank you.